states of aggregation, right? Aggregation is clustering or gathering. So we'll see three types, like the same three types, the solid, liquid, and gas, and we'll try and understand them with how these particles of these different phases are clumped together. Okay, so solid and liquid, they both together make the condensed phase, and they have much higher densities than the gaseous phase, and those are the properties that make them the condensed phase. Generally, solids will have slightly higher densities than the liquid, but both together have extremely high densities than the gas. The liquid and the gas together make the fluid phase. The fluid phase, that means they can flow, like water can flow, air can flow, they can flow. So they both constitute the fluid phase, these two constitute the condensed phase. Now, moving towards some of the macroscopic properties of these three different phases. Now, what about the solid? We know that solid resists change in its shape and volume. Like this for example, is a solid, right? So this is resisting the change in its shape. I can change it, I can change the shape of it by like applying enough force, by enough pressure, by varying the temperature. I can do it, I can change the shape, but the property is like it resists the change. That's the important point. If the resistance in change is high, if it's a solid. For a liquid, the shape changes very easily, takes the shape of the container, but the change in volume is really difficult. Like it resists the change in volume. When I was a kid, I thought, oh, liquids could be very easy to compress, but no. Like if you take a bottle of water and try and compress it, you'll see it's really hard, right? So the compressing that liquid bottle of water is really, really hard. So it resists the change in volume, although it takes the shape of the container. Now, gas fills out any volume that is available. I thought that was, when I was a kid, I was fascinating. So, if I have, say, 1 kilogram of nitrogen, and I have it in one small container, I open the container, it takes the whole of the room, right? That was fascinating. I always thought that, okay, that means we are getting more material, but that's not true. The number of particles in that container, the small container that I had with me, will have the same number of particles, but if you open the container and subject it to this whole room, the same number of particles will occupy the entire room. So the amount of gas will remain the same, the volume it occupies can be really different, right? So we will study these kind of the relationship between pressure, volume, and temperature in my forthcoming lectures. But for now, we have to understand that, okay, if we open up the container, like magic, it can like fill the whole room. Like if you open the container of, say, of a perfume, the entire room will be able to smell it, right? Okay, so moving from macroscopic properties, we try and see how these macroscopic properties can be explained by these microscopic properties, right? So you have solids which have a really clustered, arranged behavior, like they are very close to each other, like this. So imagine that this is a solid, and if you see inside the particles inside it, so it will be really clustered together. So the space between these particles will be really tight, so it won't have much space. So the intermolecular space between the particles, the intermolecular space is the space between the molecules, is really small, and they have a really strong force of attraction. So solids, they're super disciplined, right? So they do not change shape. They resist change in shape. Why? Because they're so close together and they don't move. So they're super disciplined. You keep them here, they will stay here forever, right? Not forever, but I mean, you know what I mean. So it will stay there for as long as it needs to be, right? Unless an external force is applied, right? So it is super disciplined and it resists change in both the volume and the shape. But the case is different for a gas, right? So we'll talk about liquids, but what about the gas? The gases have free movement. it's exact opposite to what we saw in solids. The solids are really confined in space, right? Although they vibrate in their own spaces, but they're not free to move. And that is why they resist change. So you keep a solid at one place, since they don't move at all, as the particles. So if they don't move, they don't change the space, right? But the gases are different. They are free to move, and that is why they flow. So they move and they fill the entire volume of the room, right? So they're free to move, and the intermolecular space is large. So as compared to the size of the molecules, the intermolecular space is a lot. And the intermolecular force of attraction is really small as compared to the solids, right? So there's not a lot of attraction between these molecules. They're free to move, a lot of space between them, and that's why they flow. That's why they can fill the room. Liquids behave intermediate, kind of like intermediate behavior. They're not as tightly bound as the solids, and that's why they're free to flow, but they're not as free to move as the gas, and that is why they can flow, they can take the shape of the container because it's kind of more free to move with less force of attraction, but it's not as free as the gas, and that's why they don't change volume much, right? So general understanding of the macroscopic properties with keeping in mind the microscopic properties is really important to understand what happens at the microscopic level. Okay,